Our third and final factoring technique that we're going to learn is called ST, or really that stands for short trinomial, or short tri for short. And we call it short trinomial because in the Algebra 2 course, you'll actually learn the other factoring technique called long trinomial. And the difference here is that this first term, our x squared term, the a has to equal 1, meaning that if there is what we call a leading coefficient or a number in front of the x squared, then that means we either have to do a GCF and take it out, or that means that we can't factor it. So if you had like 2x squared plus 3x plus 1, if you could factor the 2 out, great. But in that example I just made up, that's not going to work. There's no common factor of 2. So that means you wouldn't be able to factor that one in our course. So you don't have to worry about it if you can't factor out the leading coefficient. Now, you just got done playing what I like to call X games. The difference between playing X games and the factoring technique is now we actually have to set up the X before we can play. And the strategy here you can see in the middle. For the X, the top number is the multiplication of a and c, but because it's short trinomial and a is already 1, that's always going to be our c value. So basically it's going to be the constant term. And then the bottom, b for bottom, is going to be the linear term, or the coefficient of the x term. So if we take a look at our first example, we've got x squared plus 2x minus 8. So we build our x, and in the top we want to put c. So since it's up here, ax squared plus bx plus c, it's all plus, we want to actually put a negative 8 in the top, and then the bottom number, b, is positive 2. And then I want to think what two numbers multiply to negative 8 but add to positive 2. So I need a positive 4 and a negative 2, because 4 times negative 2 gives me negative 8. 4 minus 2 basically gives me positive 2. Now, to come out of the x, that's the new part. So it's going to look like a dots problem. We need 2 binomials. But the difference is the first term is always going to be your variable. So in this case, it's x. And the second term is whatever you got out of x games. So it was positive 4, so we need plus 4. And it was negative 2, so we need minus 2. And that's it. There's your short trinomial factoring technique. So I'll do one more with you. So in this case, our top number is positive 20. Bottom is positive 9. So what two numbers multiply to positive 20 but add to positive 9? We need positive 4 and positive 5. And then this time they switched it up and used our variable of p. So we're going to put p plus 4 and p plus 5. And it doesn't matter if it would be p plus 5 first or p plus 4 first. The order doesn't matter since it's addition and multiplication. They're commutative. So you can write the binomials in whatever order you want. All right, go ahead and try the next 4 questions, and then you can come back to the video to double check them. So you've probably checked 3, 4, and 5. I'm going to show you how to do number 6 since it does have a double variable. Whatever the first variable is that's mentioned, so in this case our leading variable is x, that's still going to be the first term in each of our binomials. But then in the x games, we're actually going to include the y's in the x. So our c value is really 84y squared. the b value, or the bottom number, is going to be negative 20, and I'm going to attach the y to it. And then we still need to think what two numbers multiply to 84 but add to negative 20. And in this case, we're thinking negative 14 and negative 6. So numerically, we can still do the x gains the way that we have in the past. But for the y's, we have to think, what can we multiply to get y squared but add still to get y? We basically just need a y in each one, because y times y will give us y squared, whereas y plus y stays y. So for our binomials, for writing out the final answer, we're going to have x minus 6y and x minus 14y. We just basically can attach a y to the end of each of them. And that's it.